Welcome back. Hey, so one of the things that we do in math is sometimes we want to tear those little logarithms into all sorts of little mini parts, which we have done in previous exercises utilizing some of our rules, right? And I wrote that down in the previous one, so I just have it sitting here. So sometimes we want to take something that is condensed and kind of expand it, which is going to then allow us to do some manipulations. But, when we solve problems in logs, frequently what we really need to do, though, is we just want to get rid of the log. And if you notice my solution in these previous questions, in order to solve that problem, I basically transitioned and I got away from logarithmic notation and tried to write it in a more simple manner, right? But again, if you look at that, the definition of log is right here. But see, I don't have multiple logs going on. I just have a single log. So I wouldn't want to set this thing equal to something. I would want to set this original story equal to something because our property of log wants one base all put together that I could then raise to a power to get my answer. So when we go on to problem number 6, we start hitting a little bit of difficulty because what you're going to notice is I have multiple logarithms. I've got two separate logs, and I would like their difference to be 2. So we keep in mind that if you have a subtraction, that means what I could do is I could condense this and have x plus 4 divided by x is 2. Now that I have a single logarithm, then what I could say is that x plus 4 divided by x should be 3 to the second power, which of course is 9. So I need some value that if I took x plus 4 and I divide it by x, I get 9. Now, there's nothing right off the top of my head that jumps out at me about that, but it's all right. Let's see what we have. If we cross multiply, x plus 4 is 9x. That would mean 8x is 4, which would make x 1/2. Now, that is not necessarily the answer that would have jumped out at me that we would have had, but that's kind of what I got. Now, I feel like I messed something up. So let me double check that. X plus 4 over x is 2. That's 3 to the 2 is 9. So 9x is x plus 4. It looks okay. Um, I got to admit, though, that I'm feeling a little nervous about that question because I thought I remembered an easier value on that I could check a little bit easier. But let's see what happens. Math, I'm going to go down to log base. It's way down here a ways. Log base 3 of 0.5 plus 4. And let's go ahead and subtract. Why is it putting that extra one there? Okay. Subtract the same thing, the log base 3 of 0.5, and hopefully we got the number 2. And we did. I will be honest with you, I didn't expect that answer to come out that way. So, same idea. We're going to be putting those together, but we do have a little bit of a nuance here because in this story, we did not have the same base. And it's really important that we do have that same base. So what I'll do is I'm going to go ahead and let's make everything log base 2. Now, the reality is most of us would like it to be log base 2 because that's just how human nature is. We see that easier log base and we want to run with it. So what you want to remember is that the log base 2 of 4 is 2 because 2 raised to the 2 power is 4. And the answer to a log is what was that exponent? So that means I have the log base 2 of x squared plus 1 minus a half the log base 2 of x squared equals 1. Now, this seems okay, but I'm still sitting in a weird spot where I would really like to condense it as a single logarithm so I could get rid of it. And I've got 2 logs and I got a coefficient. That's kind of terrible. So what I can do, though, now that I have it, is I've got x squared plus 1 on top, and then I have x squared but square rooted on the bottom is now equal to 1. Okay, now there's something a little bit hard that is kind of brewing under the surface that I'm going to address here in a moment, and because I did need to work this into this worksheet in one place. So I know that I have 2 to the first power, which of course is 2, is equal to x squared plus 1 divided by the square root of x squared. Now, this is the place where we have a little bit of a weird spot because not everybody knows this or remembers it. You probably were told that before, but if you actually square a square root, you actually get an absolute value. That's a little strange because we really haven't done much with that. So if we cross multiply is 2 absolute values of x, which means, going back in our days in Algebra 2, that means one of my values is just 2x, but the other value happens when we have negative 2x. And I know that that doesn't look like a whole lot happened, but we're going to see something here in a moment. I'm just going to move everything across. Turns out this factors to x minus 1 twice. This one factors to x plus 1 twice. And so my answers were x equals 1 from this side and x equals negative 1 from that side. Now, what I'd love to see you do is just plug it back in and see if it worked. And keep in mind, since x is being squared, if you square 1 or you square negative 1, the same result is going to happen in both of these places. See, it was an even function. Replacing any number with a negative of that number is not going to do anything. So if 1 worked, negative 1 had to work. So if we plug in 1, what is 1 squared? No, what's 1? Plus 1 is 2. The log base 2 of 2 is 1. And if we plug in 2 right here, 2 squared is 4, right? The log base 4 of 4 is, I feel like I messed something up again. The log base, okay, if I plug in 1, 1 to the 1 is 1. So the log base 4 of 1 is 0, and 1 take away 0 is, in fact, 1. 1 minus 1. 1 minus 0 is 1. There we go. We got it. It worked. And number 8 will be the last one for this particular video. I'm going to actually go a little bit off of what you would think. I'm going to make everybody log base 16 just because I like it better that way. So I'm going to go big bases this time. I'm going to go log base 16. So change a base formula says that original on top, original on the bottom, log base 16, because that's the base I want, original x, original base 2. Now, hopefully over time, you're going to see some weird things. This is going to seem difficult, but hopefully not terrible. Because I know that the log base 16 of x is being divided by this, but 16 to what power is 4 is the 1/2 power. And over here, 16 to the 1/4 power, or the 4th root of 16 is 2. Now, at first, you're going to look at that and go, oh, no, that's terrible. I don't like that at all because we're dividing by fractions. But remember elementary school, divide by a fraction, you flip it over, and you multiply, right? So that means I have the log base 16 of x, missed my x, plus 2 log base 16s of x, plus 4 log base 16s of x is equal to 7, right? All of that stuff is equal to 7. Well, I've got 1 of those logs. I've got 2 of those logs. I've got 4 of those logs. So I have 7 of these log base 16 of x is 7. Well, can't I divide both sides by 7 and say the log base 16 of x is 16, is 1. And the definition of logarithm says 16 to the first power is x, so that means my answer is 16. Now let's check it out. What is the log base 16 of 16? Well, that would be 1. What is the log base 4 of 16? Well, 4 to the 2 power is 16. And the log base 2 of 16 is 4 because 2 to the 4th power is 16. And 1 plus 2 plus 4 is 7. Now, I will tell you, if you went to base 2, you'll get the same answer. But instead of getting to this stage right here, where we had the log base 16 of x to the 7th, you're going to have log base 2 of x to Oh man, I'm trying to remember what power it was. It's going to be like 1/7 power. It's going to give you the same answer, 16. It's just going to have at the end, instead of dividing both sides, I think we end up multiplying both sides, and it's going to have the same answer. But that is just one solution, certainly not the only solution. Hopefully that helps, and I'll see you back in class. Bye-bye.